Hello again, we will now begin the webinar. My name is Mihaela Ștefan. I am a professional services engineer at Infinet Wireless. Thank you very much for taking the time to join our webinar. Today we are going to discuss about the Infinet Wireless solutions for smart cities. In this webinar we will find out what does a smart city mean and what are the advantages of adopting a wireless network implementation. We will also review some of the most important smart city components accompanied by practical projects developed using Infinet Wireless units that will highlight the key benefits in each case. Let's begin by asking ourselves, what does it mean to be smart? Well, briefly, it means to think, to understand, to assess, and to be able to make decisions. So what is a smart city and how do its processes relate to the quality of being smart? The answer is that smart cities can also accumulate information, systematize it, analyze it, and automatically make decisions in real time. Try now to consider what makes your own regional cities to be considered smart. In this case, we talk about interconnecting several cities and improving the life of the citizens with the use of technologies that include digital economy, smart housekeeping, smart environment, smart transport systems and vehicles, safety and ecology. As a broader definition, we can say that a smart city is a combination of communication and information technologies that simplify the internal processes of the city in order to significantly increase the standards of living for its citizens. There are a lot of technologies developed lately, but not all of them are present in our daily life. We will focus and discuss only about the technologies that are implemented on a large scale. Infinet will help you to accomplish all the specific tasks that are required in each case. The first area we will bring into discussion is the smart transport system. A vast range of intelligent transport systems have emerged, and we mention here the smart traffic lights that adjust to the traffic load in real time in order to significantly decrease the congestions at rush hours. Additionally, we now have smart digital screens like speed limit displays and the smart parking system that indicates the number of empty spots and their location. The public transport system also features the ecologic transport technologies, the presence of the internet in moving vehicles and public areas, GPS systems, and advanced pathfinding technologies. Next, we have the smart city environment that includes the video surveillance systems and the high-throughput links for government networks, fire stations, or police departments. Another important area is represented by the smart resources like smart sensors and smart controllers that require a resource management from one centralized location. The last category we are going to discuss about are the smart homes. These days, a smart home features surveillance systems, temperature control, smart sensors, and many other innovative technologies. We will shortly reveal more details about the smart city functionalities. When discussing about smart cities, obviously the key term is connectivity. All public service systems should be interconnected in order to ensure a seamless and efficient operation. An example of Infinet device integration with the smart city environment is shown in this picture. We will also understand why wireless connectivity is mandatory for smart cities. However, connectivity is not all. Data transport, interpretation, and correlation are also crucial. Therefore, the collected data must be transmitted to control centers error-free and as quickly as possible. This means that high-performance, reliable network equipment is required, and Infinet is one of the best choices to accomplish all these tasks. Additionally, we have professional technical support available 24/7 with Infinet Wireless. Let's now dig into some details regarding the smart transport systems. The elements that are present in such a system include traffic flow detectors, automatic traffic control, adaptive traffic lights, automatic detection of traffic rules violation, electronic fare payment, for example, parking meters, information boards, automatic control of the street lights, road weather stations, and so many others. We can see that the list is quite long, and whether we realize it or not, these systems surround us everywhere. It is now easy to understand why wired solutions would be so difficult to be implemented in an environment where digging is intrusive or not possible at all, where there are many points to be interconnected in predefined as well as crowded locations, and where the architectural design of the city does not allow for modifications. Smart transport implies also deploying mobility projects for trains and for other vehicles that serve specific industries like mining. The best serving base station is chosen automatically, and the data transfer is seamless for the end users, ensuring a high quality at any moment. On August 28, we will have a webinar dedicated for the mobility projects, and all the details will be provided at that time. Besides the already mentioned benefits of the Infinet devices, we will now review some additional key features. First of all, our base stations support an unlimited number of CPEs, which is very useful in our scenarios. You can connect to a base station a multitude of traffic controllers or other devices used for transport systems that have low capacity demands. Next, we support asymmetrical links so that the direction that is mostly loaded will receive the highest ratio of utilization. Both polling and TDMA software versions will automatically adapt and schedule the transmission based on the actual load. This is useful, for example, in the case of the video surveillance applications that have a high demand in the uplink. The Infinet units also feature advanced interference mitigation techniques like, for example, MIMO, OFDM, equalization, channel coding, guard intervals, and many others. The noise overcoming is particularly useful in dense urban areas where we have multiple devices that use the radio resources to concurrently send data, and where multiple reflections and diffraction occur in the presence of obstacles like buildings and trees. Another important technology is beamforming that has the ability to narrow and to focus the radiation pattern towards the CPE it is currently talking to. Since the radiated energy remains the same, we obtain an improved quality of the transmission, allowing also higher distances to be covered and a better communication in near line-of-sight conditions. Let's now review some success stories. Galați is a city in Romania where our partner Mobilis has implemented a new intelligent traffic management system and an improved video surveillance system in order to prevent crime. The solution was comprised of 18 Infinink XG units, 9 MMXBs base station, and 43 subscriber terminals. The new and stable, secure Infinet network was able to provide high-performance connectivity for the video surveillance and intelligent traffic management systems. The next case shows how Georgia's Regional Traffic Operations Program aims to improve the traffic flow and to cut down the vehicle emission by controlling the traffic. Using high-capacity point-to-point Infinet links, the customer benefited of the following: low entry costs, citywide connectivity, high performance, reliability, and scalability. All these resulted in an optimized traffic flow, saving thousands of gallons of fuel and ensuring a better air quality. Another challenge was to provide a reliable high-speed network for traffic management for the fast lane at Ain Socna city. Using the Infilink 2x2 point-to-point products, the network benefited of high capacity and a scalable design, allowing for new features to be quickly and easily integrated in the future. A large number of data transmission channels were seamlessly combined into a single and easy manageable platform. Next, we look onto a project in León City, Mexico, where the crime level is considered to be high, so the Aptibus transport company decided to implement a complex CCTV monitoring system in order to keep the citizens safe. With the help of the Infilink and Infiman product families, an improved real-time image from CCTV cameras was obtained. The increased capacity and high-quality transmission enabled the staff to collect and to monitor the data in real time. Featuring a completely online monitoring system, the employment costs were also reduced and the work was performed from a main office, as opposed to having extra staff that performs tasks manually in each station. Let's now move our attention to the smart city environment. Here we first focus on the video surveillance systems with cameras mounted at street level, on traffic lights and on buildings in any public place. The final goal is crime prevention in order to keep the population safe. A particular situation that requires additional ad hoc safety measures is the case of public gatherings. Along with fixed cameras, mobile CCTV systems can be used to monitor the events. Infinet Wireless provides reliable and flexible devices suitable for any practical scenario. The increased capacity and transmission robustness in noisy environments can firmly accommodate to the smart city environment demands. Another component of the smart city environment is represented by the unified city network used by the government and special services like police stations and hospitals. A wireless solution is desirable in this case, as different institutions must be connected over a spread area and the installation should be seamless without intrusions or disturbing the daily activities. In addition to the already mentioned benefits gained by using the Infinet units, we will review some particularly useful features for the smart city environment. We begin with the multicast traffic management, which is essential for video streaming. Our units support IGMP snooping, which is the best solution to avoid capacity bottlenecks and the spread of sensitive data to undesired locations. Next, we have advanced QoS techniques based on a multitude of criteria in order to prioritize the sensitive packets and to schedule the transmission of each packet based on several output queues. Traffic shaping ensures a smooth output packet ratio, making sure that a proper usage of the allocated bandwidth is obtained and improving the performance of the network by reducing, for example, the values for the latency. Last, we have the error queue feature, which is an error control method that ensures reliable data transmission by using acknowledgements in case of successful outcomes and retransmissions if something went wrong for each data packet separately. Let's now review some of the success stories. In China, Infinet Wireless linked a region using more than 90 sites with high-definition CCTV. The Infiman point-to-multipoint products were used for the last-mile connectivity, and the Infilink point-to-point products were used for the high-capacity transmission network. The benefits include an advanced quality of service, the delivery of HD images and video from all areas to designated control centers, extended surveillance in areas used as escape routes, and an improved public security level. The next challenge was to provide the government of Oaxaca, a small town in Colombia, with a cost-effective, straightforward solution to improve the surveillance of the town using CCTV cameras. The infilling solution was based on Infinet's light products fitted with 19 dBi flat panel antennas running with a capacity of 8 megabits per second. Featuring a short setup time and low entry costs, this solution resulted in the implementation of a 24/7 monitoring system, including video recording, which can now be used as evidence against criminals. Let's check now some interesting solutions for mobility projects and temporary deployments. You can see in the right corner picture a drone carrying an Infinet unit and 10 PAX batteries. This setup was used in Turkey, and up to 90 minutes of activity were ensured in order to perform surveys in a specific area. Another setup is the tripod that you see next to the drone. For temporary deployments in case of special events, you can mount the unit together with the CCTV cameras on a tripod. You can attach a battery pack and position this simple setup in locations where no power is available and for ad hoc specific purpose usage. Now let's talk about how Infinet implemented a fast, reliable and weather-resistant solution for the residents of Xinjiang in China. Infilink XG1000 was used to provide 4G mobile connectivity in rural areas in order to improve the lives of the citizens. The demands for high capacity of up to 1 gigabit per second over long distances of over 100 kilometers were successfully met. Data and voice are now being transferred with extremely low latency, providing a superior quality for the voice conversation and for the data streaming. We'll now move on to the smart resources component. Here, the concern is to gather data in real time from sensors and from other type of controllers in order to be promptly analyzed and to call for new decisions at any point. This time capacity is not so much a concern as is the quality of the transmission. The data must be available in real time, and the Infinet devices are designed to ensure low latency and jitter values, providing the desired quality in any circumstance. Next, the units feature a PoE output, which can power up your sensors with the least of effort on site. The guaranteed availability is of 5 nines, which is crucial for such sensitive applications. No one can afford to lose information because it can greatly impact the business. Last, we have InfiMonitor, a centralized monitoring system that allows you to easily maintain and react to any problem that occurs into the network. Let's move our attention to the smart homes. Technology is now present in our homes as well, and it all depends on having a fast, reliable internet connection. While your ISP will provide you with the internet plan, Infinet comes into play because it is part of the ISP backbone and it is fully capable of ensuring the capacity and transmission quality demands. As a first requirement, we now have the high throughput. Our units offer increased capacities both in point-to-point topologies of up to 1 gigabit per second and in point-to-multipoint topologies of up to 240 megabits per second, capacities that fulfill the demands for a smart home. Next, the Infinet units offer support for triple play services. Whether we are talking about TV streaming, voice, video cameras, smart controllers, our units can differentiate the traffic and provide a specific quality of service with different policies for each type of service. Additionally, the Infinet devices can operate in near loss or non-line of sight conditions, so you don't have to worry about the surrounding trees or buildings that obstruct the visibility. Last, we have prioritization rules based on multiple complex criteria, so that any type of service is accordingly managed and scheduled for transmission. Let's now see how Infinet provided high-capacity data, voice and cloud services for the citizens of Bursa Clar, one of the oldest towns in the Ankara province. Our R5000 series products offered a quick and easy installation with robust operation in extreme weather conditions. The non-line of sight connectivity was also a challenge for this project, since there were many obstructing buildings, but our units proved their good and lost functionalities. Citywide connectivity was delivered with advanced QoS features in order to fulfill the needs for transporting so many types of traffic. In the end, let's briefly review our product portfolio. First, we have the Infilink XG1000 product in the 5 GHz spectrum, featuring a superior net throughput of 1 gigabit per second, with the 2 gigabit interfaces and an SFP interface. Next is the Infilink XG, operating in frequencies from 2 to 5 GHz, with a net throughput of 500 megabits per second, and offering a high-quality transmission over long distances. Quanta 5 is a new product in our portfolio, featuring the new Octopus SDR technology that ensures high speeds of up to 460 megabits per second and would be a great asset for any network. Next is the Infilink 2x2 Pro or Infiman 2x2 base station product, depending on the antenna type that is being used. These units support up to 27 dBm transmit power and provide up to 280 megabits per second net throughput. Last, we review the Infilink 2x2 Lite or Infiman CPE that offers a net throughput of up to 180 megabits per second. It has 2 fast Ethernet ports and a transmit power of up to 25 dBm. As you can see, the product portfolio is quite rich, being able to accommodate to various specific needs. We also have licensed upgradable capacities that allow you to scale your business along with its growth. This brings us to the end of today's presentation. Now, if you have any questions, please feel free to write them down in the chat section, and I will answer them one by one. Thank you once again, and we will have a short break. After this, we will answer the questions. We've come back for the questions. You've already talked to Alexander, and I will review the questions also. Yazid is asking, when we say unlimited CPE number per sector with the TDMA firmware version, if there is a maximum number when the performance of the base station is decreasing or not. Well, if you have a lot of CPEs, you will have an increase in latency and a decrease in throughput. So as long as your application allows for a certain value of latency, you can increase the number of the CPEs. When we say unlimited, we mean that you are only limited by the type of application that you are using. If you have low demands for latency, you can use over 100 CPEs. But if you have applications like voice, the number of CPEs is definitely much lower. You also asked if in general we can say for a number. Well, let's say you asked for optimum conditions. It's not like a general rule, but let's say that in optimum conditions you might say that 32 CPEs would be a reasonable number in TDMA firmware version. Another question that we have is if the CPEs can be configured and work for the primary rate interface. It can support the transmission of the data, but you need to use an adapter because we don't have a primary rate interface. So we can sustain the quality of the transmission, the capacity required, but we don't have a primary rate interface implemented. We don't have E1 or T1 interfaces. You just need an adapter in this case. Another question is how much megabits per second does each CPE have, and how can this be deployed in point-to-multipoint topologies? Well, the maximum capacity of the light CPEs series is 180 megabits per second, but you can also use the Pro units, and they have a maximum capacity of 280 megabits per second. Basically, if your application permits, you can assign more bandwidth for a particular CPE. It should be fine. Another question is about the latency and jitter values. We are asked about how much exactly. Well, here also it depends on the application, on the type of traffic that is being sent over the network. We can have latencies as low as 3 milliseconds, but it depends on the application. You can also check the datasheet. Yazid is saying that he has 26 CPEs connected to a base station, and he's trying to provide a sustainable QoS for every CPE. Well, 26 is not much, so if your application permits it, it should work fine. You can also apply specific QoS policies and force guaranteed bandwidth and maximum output ratio, and this all can be done from the QoS module. You can check our webinars for the QoS, our documents about QoS, and you can configure specific policies in order to have different requirements configured for each CPE and to ensure a guaranteed bandwidth. One last question that I see here is if the Infinet 5G CPEs are out and on what standard. Well, for this, I think we needed to contact the development team because I don't have a particular information at the moment, but we will come back with information when it's available. At the moment, I don't have information about the new standard. One new question is from Zaid. How can I determine the maximum distance of the transmitter? And as Alexander suggested, it is best to perform a simulation in InfiPlanner, and you will get an appropriate estimation of the distance. You will also obtain additional information for the bandwidth, capacity, availability, based on the scenario that you have. I only saw one more question from Zaid. About how to choose licensed or unlicensed equipment. If you are talking about the frequency, you just have to see if the frequency that you need to use is licensed or not in your specific region, because each region has its licenses. And this way you can choose the appropriate equipment. If you refer to the license upgradable capacity, you just request for the capacity that you estimate you need in the beginning, and we will provide you a license for this. And if you decide that a higher capacity is needed, we can provide you a new license with a higher cost, of course, when needed. So you can adjust your business on the way. I think this should be all. Thank you very much for your time, and I hope to see you again during our next webinar. Have a nice day.